Hello everyone, I'm Wei Min. I'm a teacher from Shanghai Urban Construction Vocational College. I'm very glad to invite Ms. Zhang to explain the relevant knowledge of Sponge City to us. As a consulting expert, Ms. Zhang led his team to provide the professional technical consulting, the Sponge spatial planning, and the typical project design services. For example, the construction of many national and provincial sponge pilot cities such as Chongqing, Zhejiang, Xiamen, Tianjin, Suining, Hebei, Ningbo, and Qian'an. In addition, he is also keen on academic exchanges and the preparation of technical specifications. He is one of the chief editors of the Jiangsu Sponge City Construction Guidelines. Representative articles include Challenges of World Modeling Technology Today and Sponge Cities Need an Effective Safeguard System. So, Ms. Zhang, could you introduce some successful cases of sponge city construction to us?
Okay, yeah, thank you. Glad to be here to talk about this. So I would take one of the example we did for Zhenjiang City. This is about healthy water system design for a residential area, which has about 30 square kilometers of land development. So the objective of this system is to build and also to improve the natural river system, because that 30 square kilometers of land development will increase a lot of runoff and also create some flooding issue, as well as we can see the water, environmental issue or ecological issue. So the objective is to build a healthy water system for that residential area. As you can see in the image, the area covers both sides. One is to the north, about 30 square kilometers of land, and also in the south, about 20 square kilometers of land. So the river system is right in the middle. So after urban development in the future, so try to minimize the runoff impact to the natural system. So this is a fundamental thing in designing this healthy water system. So first thing, we have to understand the natural ground feature. Graph on the top is showing the elevation model. So the river part is slightly lower, so which will collect the runoff, the flow from the residential area, which will be developed in the future. But then the computer model try to input all this information into the model and showing the natural river, as we can see in the graph in the bottom, and also the cross sections, the natural stream cross sections, as well as the surrounding area. All this information will be input into the computer. Then the computer model try to mimic the natural system, try to mimic the future land development, and then try to understand the problems and highlight the risk area and give the designers some critical information regarding helping them to size the river, size the pipe system for that area. But when we are trying to achieve the health system, as we explained previously, we have to use many sponge city facility at the source. So try to mimic the natural hydrological system. So then we have to build many swales, infiltration trench, rain gardens, all these green infrastructure at the source, as well as working together with the pipe system and the river system to form a whole system. So that is the design concept. Then the computer model is to put all this information into the model, then mimic the natural performance of the system. As we can see here, the whole system, from the eastern to west, I think it was 3 kilometers long, I think. Then each section has got different functionality, because all these things you have to think about the river functionality as well as the features required for the land development, where people want some entertainment. Maybe people want to have some walk around, whatever, enjoy the environment. Also want to achieve natural, the beautiful scenery in the area. So all these functionality have to be considered within the system. Again, the computer model has to provide fundamental critical figures for the designer to design the system like this. But so the project lasted for about 1 year. So we did a lot of computer modeling, work with designers, work with the construction team, end up to a design, and also now it's already built. 8 years ago, you can see some side photo. It's a built photo. So the natural water system, it's quite clean, environmentally quite friendly, and the people can wander around in a lot of space for people living near there, and the water is quite clean, achieved healthy situation. There are a number of sections. Different sections got different functionality. The section we see here is a big square, green square, because they're supposed to do, people can dancing as well. They want to do some exhibition and some maybe sports as well. We'll be servicing people to live there. But in flooding season, this area might be flooded. So this is a concept to build and in the spontaneous development. As we can see here, we consider the ecology, consider the plants, the water level, depth, velocity, and also surrounding area. All these features were considered in the model, in the design, and also in the construction. So the side photo is showing us at the moment it's built, it's quite clean. Yeah, look quite nice. It's a quite beautiful area. So people like to go there, wander around, have a look. That achieve the purpose. Like the natural infiltration change, rain garden. So in dry season, it's just like people don't notice. The beautiful plants just grow, but in the rain season or in flooding season, it will serve the purpose. It was implemented 8 years ago and examined also a few years ago, during a big storm event as well. Yeah. So some other side photos like permeable paving, we use a lot, and also wetlands, lots of wetlands. But all these distributed sponsored facility eventually were linked by minor drains or small pipes and end up to drain to the river system. So the rainfall response in this small area, it lasts for about 3 days. So slowly, and also some water will infiltrate to the ground, but infiltration change swell and rain gardens, and then gradually move to a downstream river. And so the water is purified, it's clean, and also move slowly. Yeah, they're clean. Yeah, that achieve the purpose.
Thank you so much for the successful cases shared with us. Could you talk about future development of smart city construction?
Yeah, thank you. It's a good question. In China, we have been implementing smart city concept for about 10 years. I would say learned a lot of lessons, also obviously gained a lot of experiences. The smart city really is a very complicated concept. Even globally, people are using smart city concept, and also earlier, people were talking about the LID, low impact development, and also now people are talking about resilience. So all these things are related. We are still developing smart city, I would say, in China, because smart city, as we can say, really about the city's safety, amenity, and also ecological beneficial objective as well. So we want to achieve all these balances when we are developing the city. So it's about many things. So as we can see, it's very complicated. It's not just about stormwater, not just about the environment, not just about ecology. It's about a city, about people, about how we build things, how we manage things, how we want to build it nicely, smarter, in a better way. So about optimization, about the management. So the smart city really includes all these aspects. Then everyone is involved, not just the people in this field, not just people managing the city. Actually, people living in the city should also be involved, about people behavior, about people understanding, so about everything. So then how we develop, what is the future? Concept is clear, but to achieve the concept, we need to have a clear view or clear pathway to achieve the concept. But then technically, we need to understand this one even better, do more research, do more experiment projects maybe, and also implement projects in different cities as well, again and again. We need to learn lessons. We need to, through the monitoring, through evaluation, understanding the issue in a better, and then we can move on to the next stage. So I think the future sponsored development still will involve a lot of research, a lot of practice, and a lot of monitoring and evaluation of the practice again and again, and then gradually forming a clear regulation, a clear way of management system, and also everyone understands this one. Then we can, move into a next phase. That's the first one. And as we can see here, there's so many things to happen. Then for a system, planning is very important. It's so complicated, but again, we have to go through planning phase, which is important to shape the spongy city for the future. That's one thing. If we fail to plan, the plan will fail. This is very, we know that, So planning is very important. Second one is scientific, make it right, reasonable, practical, also very important. Because it's so complicated, we still have to, through research, research and also practice, to try to make it right, make it practical. And then we can implement smart city, more smoothly for the future and achieve the purpose. So how to achieve that? Technically, I would say, because there are so many things happening in research, whatever, we still need to rely on keep monitoring, keep implement evaluation, understanding the problems, learn lessons, and also computer modeling again will be a very powerful tool to allow us to understand the issues and also to make better suggestions for planning, for policy making, for design. So modeling is so fundamental, I would say, in the whole process.
Could you talk something about monitoring for smart city?
In human history, people make mistakes. Engineering, we make mistakes, but we learn mistakes. Engineering is about learn mistakes. So how we learn mistakes, how we understand we had made some problems and we try to, correct our mistakes. You have to do research, but the research has to be based on what you learned. So monitoring is a fundamental tool to help us to understand what's wrong, where could have been wrong. So, but again, monitoring still have to be assisted by evaluation. Normally we use computer model. So monitoring will collect the data from the system. Then computer model will help us to understand the problem, to even deeper level. That is what we normally do. So again, after monitoring, modeling, and then you learn lessons, and you make improvements in your design, in your practice. And again, whether we achieve the purpose, again, you still have to monitoring. So it's a dynamic process.
Thank you so much, Ms. Zhang.